Hello from OG Benchmarks. As I have drifted toward the ITX form factor, I've learned that there is both a mini-ITX and thin mini-ITX. In this video, I'm going to talk about the differences between the two and how the differences affect a build. Depending on with whom you speak, there are 7 or 8 key components for a computer build. I'm going to go with 8 for this video. Those 8 components are on the screen. Whether you are designing a mini-ITX or thin mini-ITX, just about every one of these 8 components will be affected. Okay, maybe storage decisions won't change, but everything is definitely up for discussion. I'm going to start with the heart of the system, the motherboard. Note that each of these parts affects others, so the discussion will not be as compartmentalized as I'd like. Here are 2 typical motherboards. On the left is the usual mini-ITX board, the ASRock B460M ITX AC. On the right is a typical thin mini-ITX board, the Asus Pro H410T CSM. Aside from some layout differences, maybe the most striking difference is the height of the rear I/O of the board. We can see this at the bottom of the screen. The thin board is shorter, a lot shorter. This is the thin aspect of thin mini-ITX. With a low profile rear I/O comes a low profile rear I/O shield. Here are 3 I/O shields. The top is a standard I/O shield. The mini-ITX takes a standard sized I/O shield. The standard height is something close to about 45 millimeters. Just about all motherboards, ATX, mATX, and mini-ITX have this same size I/O shield. The thin mini-ITX I/O shield can have a low profile, around 25 millimeters. That is the middle I/O shield. What's kind of interesting is that the thin mini-ITX boards normally are also sold with a standard height shield as well. That's the bottom I/O shield. The cutouts for the I/O output are still low profile, except for the optional Wi-Fi antennas. But the backplate has a typical 45 millimeter height. This allows a thin mini-ITX board to be used in a case with a standard I/O cutout. That naturally takes us to discuss cases. A mini-ITX board has almost no restrictions on its case. Of course, most people get a mini-ITX board so they can build in a smaller case, a smaller form factor build. Here on the left is an ITX case from Cooler Master. It is smaller than a typical case, but still large enough to handle features like a full-size GPU and even liquid cooling and a radiator. The rear of the case has a standard I/O shield cutout. A mini-ITX build can be as small as this tiny case on the right. It's around 200 by 200 millimeters. The minimum case height is about 60 millimeters, which still gives room for the standard sized I/O rear panel cutout clearance of around 45 millimeters. You probably can't include a discrete GPU in this tiny case, but you can build a PC in there. How is the thin mini-ITX different? Well, it's not if you use a standard sized I/O shield. If you use the low profile shield, however, you can use extremely small cases. Here is the image of one of these cases. It's only 45 millimeters thick and has just a 25 millimeter tall cutout that will only fit a thin mini-ITX board. These types of cases are often sold as mini PC cases or HTPC, home theater PC cases. To my knowledge, this is the main use for a thin mini-ITX board. And when I talk about a thin mini-ITX build, I'm going to assume a mini or HTPC is the goal. These HTPC cases are extremely small. They are all around this exact size, 45 millimeters tall, and approximately 200 by 200 millimeters in the other dimensions. That's just enough space to fit the ITX board, which is around 170 by 170 millimeters. A case of this size has a total volume of about 1.5 liters. It can easily sit on a bookshelf or on top of a desk. It can easily fit in a media center. It can be mounted to the back of a monitor to reduce clutter. This is the coolness of a thin mini-ITX build. Of course, fitting an entire computer into such a small volume poses some challenges for other components, even if you can get the motherboard into one of these wee tiny cases. An easy component to discuss is the RAM. Here are our model mini-ITX board and thin mini-ITX board side by side. From a RAM standpoint, you may have noticed that the mini-ITX board takes regular desktop RAM sticks, UDIMMs. It's kind of hard to see in this dark image, but those are regular, everyday desktop RAM slots. Mini-ITX boards go into taller cases, so having RAM sticks that stick up vertically on the motherboard is not an issue. For thin mini-ITX boards, you're restricted to laptop RAM, SO-DIMMs. They lie flat on the board. Remember that in a thin build, the case is about 45 millimeters tall. So the interior dimensions, including motherboard standoffs, are going to be even lower than 45 millimeters. The RAM needs to lie flat. Next component, the CPU. The CPU is not a concern from a size perspective. The socket for a mini-ITX or thin motherboard is the same. There aren't small CPUs for a given socket. There are, however, higher power CPUs for a socket. Power is relevant. Power delivery is relevant, and the cooling consequences are also relevant. That takes us to other components like the CPU cooler. All ITX builds tend to be in smaller cases, so clearance on the CPU is relevant. A thin build, however, is especially restricted. If you are building in a 45 millimeter case, there are only a handful of different coolers that even fit on the CPU and don't extend past or even touch the top panel of the case. Manufacturers of CPU coolers don't always disclose accurate cooler heights, but coolers that can be mounted in a thin case need to be less than 27 millimeters high. On the screen are 4 coolers. The Titan here in the upper left, which is advertised as low profile at 30 millimeters, is too tall. It's too tall for a 45 millimeter case. The high power in the lower left is just 27 millimeters tall. But that's also just barely too tall based on my experience. The Silverstone Tech in the upper right is just 23 millimeters. That's fine. The no-name cooler in the bottom right is listed at 16 millimeters tall, and it fits fine as well. Here's another concern. The job of the cooler is not just to fit in the case, but also maintain decent CPU temperatures. These smaller coolers on the right, with their smaller fin stacks, are perhaps less effective at cooling the CPU. So this takes us back to selecting a CPU for a thin build. If you're in a tiny case, you'll probably want to focus on 35 watt CPUs. Most of these low profile coolers claim to handle a 65 watt CPU, but temperatures tend to be quite high, especially when 65 watts is the base power and the CPU then turbos well north of that number. The CPU cooler also doesn't get any help from case fans, since these tiny cases don't have space for worthwhile case fans. So instead of trying to cram better cooling into a smaller volume, the simpler answer is often to use a CPU with a lower TDP so there's less heat to handle in the first place. The thin mini-ITX builds are normally not powerhouses. Speaking of making heat, how does a thin ITX build affect the GPU? Let's go back to our motherboard view. Typically, mini-ITX boards, like the one on the left, have a full 16-lane PCIe slot, so it can theoretically handle any GPU you want. Of course, you'll need a power supply and adequate case volume to match. Note that the thin board on the right has no PCIe slot. Actually, some thin boards do have a PCIe slot, but it normally has only 4 or maybe 8 lanes. If you read the board manual, it may also have very limited power output, like even just 25 watts. So options for an internal discrete GPU with a thin mini-ITX board are extremely limited. If you are aiming for a 45mm high case, then your options are down to just one option: integrated graphics. In this case, the GPU question really comes back to the CPU. Suffice it to say, these tiny PCs are not gaming rigs. That doesn't bother me too much. Minecraft, Roblox, and low-end Steam games are just fine, at least for me. Many people, of course, are more focused on higher quality games. Note that newer CPUs can have low power and a reasonably good iGPU. Intel's UHD 750 graphics are much better. AMD has some Ryzen GE CPUs that are both low power and equipped with decent graphics. This is a compromise on performance. If gaming is a must, then a thin ITX build likely won't be satisfactory for you. I've put off discussing the power supply as long as possible. It's messy, so let's look at a few scenarios. The first is easy. Larger ITX cases have space for a full ATX power supply. The typical ITX motherboard has a standard 24-pin connector, barely visible in this image, as well as a 4 or 8-pin CPU power. And everything works like any other motherboard. Some smaller cases require an SFX PSU. The connections are the same, any smaller, and the PSU gets ejected from the case. For a smaller PSU, you need to use a power brick. The motherboard connects via its 24-pin connector to something called a Pico power supply. The Pico power supply then runs a line to the back of the case to pick up DC power. The DC power at the back of the case comes from a power brick, which converts the AC from the wall to DC. So the Pico power supply takes the DC from the power brick, often 12 or 19 volts. The Pico power supply then converts the higher voltage down to everything that the motherboard needs: 12 volt, 5 volt, 3.3 volt. Using a Pico power supply takes some planning. The Pico PSU must be rated to deliver the power you need for your system. The Pico PSU also needs an adapter that goes to the back wall of the case for connection to the cable from the power brick. There are different connection types, and everything needs to match. This is all fine for a mini-ITX board, but how about a thin mini-ITX board? The thin boards are very different. Here is a thin board. Note that there is no 24-pin connector on the back edge of the board. Power delivery to thin mini-ITX boards will always involve an external power brick. There are two options. One, and far more common, is to connect to a barrel jack on the rear I/O panel. Thin ITX boards all seem to have this connector. Regular mini-ITX boards almost universally do not. Different thin ITX boards have different barrel jack configurations. Many are 19 volt with a 9.4 by 5 millimeter plug. Some are 12 volt with a 5.5 by 2.5 millimeter plug. A few are less picky about the exact voltage and accept anything from 12 to even 24 volt input. But the jack still needs to be the correct size. You'll need to read the manual for specifics. The motherboard does the rest of the work in stepping down the higher voltage to feed whatever voltages the components need. The second option involves a little 12 volt connector, which is typically right behind the barrel jack connector. This is either a 2-pin, as shown on this board, or a 4-pin connector. You could power this board from a Pico power supply. You could run a 12 volt line to this connector and power the entire motherboard. Of course, you would need to run a separate line from the Pico PSU to a jack on the back of the case to access whatever power brick you have. Note that the barrel jack and the pin connector next to it are mutually exclusive. You can run power through the barrel jack, or you can run power through the pin connector, but not both. With a 35-watt CPU, a 90-watt power brick should be plenty. If you step up to a 65-watt CPU, you may want a 120-watt power brick instead. Finally, let's talk about storage. For a mini-ITX board with an ATX, SFX, or Pico power supply, there's no difference from any other build. You have all the internal power connections that you need, whether SATA or Molex. You do have less space than an ATX or micro ATX build, but the ideas are all the same. You need to power your storage device, whether it's some kind of drive. All the power can come from your power supply. It doesn't quite work that way for a thin ITX build. For a thin ITX build, if you want to use a drive, almost certainly an SSD, then powering the device is an issue. Keep in mind that all the power in the case is likely coming directly to the rear I/O of the motherboard. Therefore, power for the drives has to come from the motherboard itself. There are three options, and they depend on the design of each thin ITX board. Option 1, Molex. Some boards, older boards, will have a Molex connector on the board itself, and you can run a Molex to SATA power cable into the SSD. Option 2, some boards, again, these are older boards, use a weird 4-pin power connector. This isn't a fan connector. It's some strange thing that requires a 4-pin to SATA power line. These cables are not hard to find, but it can be hard to match the seller's description when you search for these cables. They are out there. Option 3, some boards have a male SATA power connector on the board. A female-to-female SATA power cable is all you need for the SSD. All thin mini-ITX boards have standard SATA data connectors, so while power is an issue, moving data is not. One last option that may allow you to avoid power cables altogether. Depending on the vintage of the board, you might have a mini SATA or M.2 slot on the board. If that's the case, you can get the corresponding drive, plug it straight into the board, and bypass needing power and data cables altogether. That's especially nice for a very compact case because even small cables make things crowded very quickly. That is a rundown of some of the factors you want to consider for a thin mini-ITX build relative to a regular mini-ITX build. Every key component is affected. Not all the decisions are hard. For example, there's not much to consider about the GPU. You're stuck with an iGPU. I hope you found this video somewhat informative. The ideas in this video are not a secret by any means, but some of it is hard to scrape together on the web. Please consider subscribing, liking, or leaving a comment. Take care.